We're going to talk about temperatures in Celsius and Fahrenheit. So let's say you're in Detroit, Michigan, where a temperature is measured in Fahrenheit, and across the river in Windsor, Canada, it's measured in Celsius. So how can you figure out, well, what is the temperature? And there's a formula to go from Celsius to Fahrenheit. So if you are in Canada and your temperature is in 0, 100, or 25 degrees Celsius, what Fahrenheit temperature is that? So what you do to figure that out is plug the Celsius temperature in here. So if the temperature is 0, we would go 9 fifths times our input of 0 plus 32. And that would be 0 plus 32, which is going to be 32 degrees Fahrenheit. So just type in or put in 32. Well, what if it's 100 degrees Celsius? What is that? So F would equal 9 fifths times 100 plus 32. And we can use a calculator for that. So we just put in 9 divided by 5 times 100 plus 32 and get 212. Now remember, that's probably not going to be outside temperature. That might be boiling point for water. So that is 212 degrees Fahrenheit. What if it's 25 degrees Celsius? What is that Fahrenheit? So just plug that in. So your Fahrenheit temperature is 9 fifths times 25 plus 32. And that would give us 77. Now, if we were going to plug in our Fahrenheit temperatures and get Celsius, it helps to use the inverse equation, or if we were to solve this equation for C. So what we're going to do is do just that. So I'm going to switch the two sides of the equation right here and write 9 fifths C plus 32 equals F. Then I'm going to subtract 32 from both sides and get 9 fifths C equals F minus 32. And then we're going to multiply both sides by 5/9 to get rid of the fraction. To do that here, I'm going to put parentheses and then put in 5/9. So my Celsius temperature is equal to 5/9 times, in parentheses, my Fahrenheit temperature minus 32. So if I'm looking at if it's 104 degrees Fahrenheit, what's the Celsius temperature? You just go 5 divided by 9 times, in parentheses, 104 minus 32, and you get 40. Same thing here with 50. We'd go 5 divided by 9 times 50 minus 32, and that gives you 10. And then what if it was 62.6? So 5 divided by 9 times, in parentheses, 62.6 minus 32, and you get 17. So now we have this equation, R equals 9 fifths times C plus 273.15, which it determines the temperature in degrees Rankine as a function of the temperature in Celsius. So show that the equation C equals the Rankine minus 491.67 times 5/9 is the inverse. So what we would do here is go R equals 9/5 times C plus 273.15. Now I'm going to solve for C. So first I'm going to get rid of that 9/5 by multiplying by 5/9. So that will cancel that part out of it. And we have 5/9 times the Rankine temperature equals the Celsius temperature plus 273.15. So now what I'm going to do is subtract the 273.15 from both sides. So 5 divided by 9 times the Rankine minus 273.15 is equal to the Celsius temperature. So this equation, the Celsius is 5/9 times R minus 273.15 is our inverse equation. Now, if you notice, it does not match this equation. So to show that this would, we have C equals, what I'm going to do is just distribute this. So we would go 5/9 times R. So far, it's looking familiar. And then we go 5/9 times negative 491.67. So here, 5 divided by 9 times negative 491.67. And it's negative 273.15. So if you notice, those two equations match.